Now, in this situation, we're going to look at what happens if we change the concentration of one of the reactant or product concentrations. What we know is that if a reactant or product concentration is decreased, then the system will shift to replace that lost concentration. So let's look at a few examples. If we have this equilibrium system, let's say that we somehow were able to remove the NO2 gas as it was being formed. So let's decrease the amount of NO2 that's present. Le Chatelier's principle predicts that the reaction will shift in the direction to replace the lost component. In this case, we're losing the product, so which direction will the reaction shift to replace the lost component NO2? The reaction will shift to make more of it. In other words, the reaction will shift to the right to produce more of the product. The same principle applies if we were to eliminate or remove some of the reactants. If we were to remove some of the oxygen gas, then the system would want to restore that equilibrium by forming more oxygen gas. And how could we form more oxygen gas? We could form more oxygen gas by having the system shift to the left. And so if we remove oxygen gas, Le Chatelier's principle predicts that the system will try to restore equilibrium by shifting to the left. And so the same principle can be applied if we wanted to increase the concentration of one of those components. If, for example, we increased the concentration of NO on the reactant side here, so let's say this increases, what would Le Chatelier's principle predict in terms of which direction the system will shift to restore equilibrium? If we're increasing a reactant, Le Chatelier's principle says the system will shift to counteract that effect. So it will shift to decrease NO, to use up more NO. And which direction is using up the NO gas? The reaction would shift to the right to remove the extra NO gas and thus achieve equilibrium once again.